Hi, my name is Lynn Ballas, and I am reporting on our Topic 5 lab for thin layer chromatography. This analysis was performed by using the thin layer chromatography. Thin layer chromatography is a method that is used to separate and analyze mixtures by exploiting the different affinities of compounds for the stationary and mobile phases. Typically, it is used in the analysis of drug residues. It can be used to help determine the number of compounds in a mixture. It can identify the compounds, and it can also be used to evaluate the purity of a compound. For this lab, the thin layer chromatography, the experiment, methanol was used as the solvent. And we were testing a few different samples, 6 to be precise. They were Benadryl, aspirin, caffeine, ibuprofen, Tylenol, and Excedrin. We took 20 milligrams of each sample and we placed it into test tubes with methanol. The test tubes were then covered and shaken very vigorously. This took a while. This was about 45 minutes of the lab to make sure that the compounds were completely dissolved. You wanted to make sure that there was no solid matter left, so we really shook vigorously. Then the test tubes were put aside, and we took 5 mLs of methanol and we put it into a beaker and we covered that, allowing it to equilibrate. When we then took the TLC plates, the thin layer chromatography plates, and we were very careful to make sure that you did not touch the side, only touch the sides of the plates. We did this because we didn't want to contaminate the plates at all with anything on our hands. So it was very vital to make sure that you handled these very carefully. A line was drawn 1 centimeter from the bottom of the plate. There were 2 plates that we used and 3 drug samples on each plate. On the first plate, we took a drop of the Benadryl and we waited for that to dry. We took the same plate and a drop of the aspirin. We waited for that to dry. And then we took the third caffeine sample and put that on the same plate. We waited for that to dry as well. Then we went back and we put another drop of each sample right on top of that sample, making sure that we really only had small little drops so the drops didn't spread and hit one another for contamination. We did the second drop for each drug sample. We waited for that to dry, then went back and did a third drop and waited for that to dry. While that was drying, we took the second plate for ibuprofen, Tylenol, and Excedrin, and we did the same exact procedure. We took 1 drop of each one and we made sure it was dry, took a second drop, made sure that was dry, and then added a third drop and made sure that was dry. While the second plate was drying, we took the first plate and we put it into the developing chamber, which was the methanol, and we covered that. The methanol was then allowed to travel up the plate until we noticed it about 1 centimeter from the top. That plate was removed from the chamber and we had a line drawn again where the solvent ended. The first plate was air drying while we put the second plate in the developing chamber, and we did the same. We took it out and we drew a line 1 centimeter from the top after it moved up to that point. We then allowed both samples to air dry, and once they were both dried, the distance the solvent traveled was determined. It was measured. Then a non-destructive visualization occurred where we used the UV red light, and that was used to mark the center of the colored spots. So we noticed where the spots were on the plate, we circled them, we filled in where the center was, we took note of the shape and the color of each sample, of each spot. The size and the color was noted, some of them did not have any spots or size, or the color was, non-existent. The retention factor was then recorded for each drug sample. The retention value is a ratio that helps identify and compare compounds in a chromatographic separation. It measures how far a substance travels in relation to the solvent front, calculated by dividing the substance traveled by the distance the solvent travels. It essentially quantitates the compound's movement up the stationary plate. Our data for this lab, the Benadryl sample, the distance traveled by that sample was 0.5 centimeters. That was divided by the distance traveled by the solvent, which was 6 centimeters, giving us a retention value of 0.08, and that was for Benadryl. Our aspirin distance traveled by the sample was 0.2 centimeters, divided by the distance traveled by the solvent, which was 6 centimeters, and that gave us a retention value of 0.03 for aspirin. Our third sample on that first TLC plate was caffeine. The distance traveled by the sample was 0.4 centimeters, divided by the distance traveled by solvent was 6 centimeters, giving us a retention value of 0.06 for caffeine. Our second plate held ibuprofen, Tylenol, and Excedrin. For ibuprofen, the distance traveled by the sample was 0.3 centimeters, and the distance traveled by the solvent was 6 centimeters. The distance traveled by the sample of ibuprofen divided by the solvent distance was 0.05, and that gave us the retention factor of 0.05 for ibuprofen. Our next sample on the second plate was Tylenol, and the distance traveled by the sample of Tylenol was 0.6 centimeters, and the distance traveled by the solvent was 6 centimeters. So the distance traveled by the sample of Tylenol was divided by the distance traveled by the solvent, giving us a retention factor of 0.1 for Tylenol. Our last sample on the second plate was Excedrin. The distance traveled by the sample of Excedrin was 0.3 centimeters, and that was divided by the distance traveled by the solvent, which was 6 centimeters, and that gave us a retention value of 0.1 for Excedrin. We then took the plates and we drew a picture of the plates, noting again the size and the shape and the center of each spot. There are two key phases when we are using thin layer chromatography that we are looking at, and they are the stationary phase and the mobile phase. The stationary phase in this experiment was the TLC plate, and the mobile phase was the solvent of methanol. Substances move across the stationary phase at different rates because they have different varying attractions for the stationary phase. These substances that move across the stationary phase and have a strong attraction for the stationary phase tend to stay there longer, so they move slower and they move a shorter distance up the plate. These substances are more polar, and substances that have more of attraction towards the solvent will move through the stationary phase quicker, and they will have more of a distance traveled up the plate and are considered non-polar. The thin layer chromatography test is considered a presumptive test. This is because it can provide visible differences in the substances that are tested. However, there is some overlap in the retention factors and the colors as well. So because of these overlaps, we say that it does provide a reliable basis for identification, but because of the overlaps, we need to make sure once we've identified using the thin layer chromatography, we need to follow up with a confirmatory test afterwards. I really thought this lab was very interesting to watch each solvent move up the plate and watch the affinity for the stationary phase and the difference of each sample. I thought it was very interesting. I appreciate your time. Thank you for listening. Bye.